experienced and judged on the basis of the various, or you can say, they just please switch off your basically
Okay.
mic.
So, so-
Yeah. So it can only be seen. Force can be judged by the effects which it can produce in various bodies around us. Okay. So suppose
yes,
that a small ball, suppose a cricket ball, basically hit the batsman, right? So how much it will hurt? It depends, right? And a football. So we will be judging the force on the basis of the impact. Okay.
yes,
Okay. Okay. So now a force. Now let's talk about force. A force can move a stationary body. Okay. And force can stop a moving body, right? And a force can change the speed of a moving body, right?
yes,
And force can also change the direction of a body, and force can change the shape and size of the body as well, right? So all these are the effects of the force, right? So this is observed when the force is acting on a body, right?
yes,
Next is a force. It's the definition based on the effects of force. A force is an influence which tends to set a stationary body in motion or stop a moving body, or which tends to change the speed and direction of a moving body, or which tends to change the shape and size of a body. Clear?
yes,
So
yes,
this is the definition of force based on the influence, or you can say based on the effects of the force quantity. Am I
yes,
clear?
yes,
Yes, sir.
Chalo, that's great. Okay, so this is the simple definition and the introduction to the force. What happened, Ifran? Do you have any issue with the camera? Irshad, same to you. So why
So,
didn't you switch on the video? Yes, Ifran, you're saying something.
I turned on my camera.
Okay, Irshad. Yes, Ifran, you're saying something.
Yes, I turned on my camera.
You cannot switch on the camera.
No, no, sir. I turned on my camera.
Okay, so please switch
Then,
on it. Okay, sure. Check it. Because if you switch on your videos, na, so I will be able to see your faces and interact very well. So as this is a class, okay. So if we are in the in the offline mode, so that would be good. But right now we are in the online mode, so only interaction that can be happened is the facial interaction. Okay, Sarah has joined. Hello, Sarah. Assalamu alaikum. How are you?
Walaikum assalam, sir.
How are you?
I'm fine. How are you?
Okay, I'm good. I'm good. Thanks so much for asking. Okay, so okay, Sarah, I've just discussed the effects of force. The first topic we are doing the division of force, right? So I've discussed that a force is a push or pull. Okay, and force is basically a quantity that we observe in our day-to-day life but cannot be seen. Okay, and we have studied about the force effects like stationary body. It can move a stationary body. It can stop a stationary body. It can change the moving body speed, and it can change the direction as well as the shape and size of the body. Okay. So
yes,
right now, this is the very basic thing that we have discussed so far, right? So now we are going to discuss the next category, the general category of the forces that is called balanced and unbalanced forces. Clear? Tejas,
yes, yes,
Astitva,
sir.
Farhan, Safi, and Sarah. That's great. Okay. Anirsha. Ifra has left. So let's understand what is the force. Okay. Balanced force. So balanced force is the resultant of all the forces acting on a body is zero. It means that if you add all the forces acting on the body, the sum should be equals to zero. So those forces are called as the balanced forces. Am I clear to all of you?
Yes, sir.
Any
Yes, sir.
doubt so far?
No,
No,
sir.
sir.
No, sir.
That's great. So now let's see the example. So as you can see, this is the box. Heavy box is lying on the floor. So as you can see, it cannot move. So if I push this box in this direction, a force of friction will be acting in the opposite direction. If I am pushing this box in this left direction, force of friction is acting in the right direction. Because force of friction acts in the opposite direction. Got it?
Yes, sir.
Chalo, that's great. Okay. Sarah, what happened? Why did you switch off the video? Please switch it on. Okay. So, and one more thing is that, so this is the force of gravity. It means that weight of the box is downward. So as I've told you, there is a force called normal reaction force. That is the force which is exerted by the ground on the box. Right now, box is exerting on the ground, but opposite force would be ground on the box, right? So that
Yes.
force is called reaction force or normal force. So both are cancelling each other due to the same magnitude in the opposite direction. Clear?
Yes, sir.
That's great.
Yes,
Okay.
sir.
So this is how the forces are balanced. Am I clear?
Yes, sir.
That's great.
Yes, sir.
Okay. Yeah. So this is the force. So that's why it is called balanced forces concept. Okay. So if the number of balanced forces act on a stationary body, the body continues to remain in its stationary position. If suppose that body is lying on in a rest position, it means that if the balanced forces are there, you can say the forces are acting, but still it is balanced, right? And they are not able to move it. So that's why the body will remain in the stationary position. Clear?
Yes, yes.
And if a number of balanced forces act on a body in uniform motion, the body continues to be in the state of uniform motion. It means that body is moving with a velocity v, right? And balanced forces are acting on it. It means that balanced force will not produce any acceleration, or it cannot change the direction of speed, because the force are getting cancelled by each other. The sum is zero. So that's why the body will continue to move in the uniform motion. Am I clear to all of you? Please do let me know.
Yes, sir. Yes, please.
Yes,
Does
sir.
anybody have any doubt?
No,
No,
sir.
sir.
Okay? Please do let me know.
Yes, sir.
Yes,
Please.
sir. Yes, sir.
Sure, that's great. Next is balance force cannot produce motion in a stationary body or stop a moving body. So please do understand this thing, that balance forces cannot produce any motion in the stationary body, or it cannot stop a moving body, because the sum of the magnitude would be zero. Clear, everyone?
Yes, sir.
Yes,
They
sir.
can, however, change the shape of a body. So as I've told you right now, I don't have the ball with me. So I have given one example when we were discussing the balance forces. I had a spongy smiley ball. So I was basically pushing like this, right? So you must, like, do you remember, everyone? So those who have
Yes, sir.
attended the class, they do remember. So I did explain with the spongy or smiley ball. So it can only change the shape of the body because forces are applying in the opposite direction. My hand, this hand is applying in this, and this hand is applying in this. So force are getting, so it will get compressed, right? It will change or you can say deform the shape of the body. Am I clear to all of you?
Yes, sir. Please.
Okay, that's great. Sarah, are you there in the class?
Yes, sir.
Okay, so do you have any issue, Bache, while switch on the camera?
No, sir.
Please switch it on. So it is on. Yes, Ifra. Still not able to see your video.
Sir, actually, I'm doing the class on the mobile phone and when
Okay.
turning. Yeah.
Okay. Okay. Chalo, ठीक है, कोई बात नहीं. Okay. So, okay, check. So it's a request to all of you. Please choose a device in which front camera is there. Like you can switch it on. Okay. So
Yes.
that's why we can interact well. Okay. Chalo, that's great.
Yes.
Okay, next thing that we are going to discuss is this clear to all of you? Balanced forces, Ifra,
Yes, sir.
Sara,
Yes,
Tejas,
sir.
Astitva, Irshad, and
Yes, sir.
Safia.
Yes, sir.
Yes, sir.
Farhan, clear?
Yes, sir.
Sure, that's great. Okay, next thing is the question is unbalanced forces. So if the resultant of all the forces acting on a body is not zero, so if you add all the forces and the sum is not coming to be zero, right? The resultant is not coming to be zero, then the forces are called unbalanced forces. Clear, everyone?
Yes, sir.
Yes, sir.
Chalo, that's great. Okay. So unbalanced forces can move a stationary body, or they can stop a moving body, right? So they can stop a moving body as well as they can produce the motion in a rest body, right? So this is a car, toy car. You will exert the force the push is in this direction, the car will move with some velocity v. So you can see this thing, car is moving. It means that the force of our push is greater than the force of friction. So that's why the car is able to move in the left side, yes or no, with some velocity?
Yes, sir.
Yes.
Yes or no, everyone? That's
Yes, sir.
so our force is basically our force is greater in magnitude than the force of friction, right?
Yes.
So the
Yes, sir.
total, the net force that is acting on the body would be, suppose our force is F and the force of friction is small f. So it means that our F is in greater in magnitude minus F, because friction is also acting. So then it will get subtracted. So the remaining force that is acting on the body will produce the motion. Is this clear to
Yes.
all of you? This is a very
Yes,
important
sir.
concept, everyone.
Yes.
Yes,
Yes.
sir.
Net force would be like this. So so this is the force of our push, right? And this is produced by A. And yeah, so net force would be,
The net force is friction force minus
no,
like
not frictional, they just
force minus frictional force, right?
F minus F. And and as you can see, this thing, car is only traveling along horizontal. It means that it is traveling in one dimension. And the force, it means that force of gravity and force of reaction are cancelling each other due to the same magnitude. Because the force of gravity, the weight of the car will not change, right? So the normal
Yes, sir.
reaction would be same, the opposite
sir.
direction, right? So that's why
Yes, sir.
only the car is basically moving or producing any motion into the horizontal way. Clear, everyone?
Yes, sir.
Any doubt so far? Ifra, Titva,
No,
Tejas,
sir.
No, sir.
Sarah, and Irshad and Farhan.
No,
Safia.
sir.
No, sir.
Chalo, cheek. Now let's understand. So let's understand the basic thing about the unbalanced forces, that we have to push the body with a force greater than the opposing force of friction to move a stationary body. So to generate, or you can say to produce a motion in a body, so you have to overcome the frictional force. Am I clear?
Yes. Yes, sir.
Chalo, that's
Yes,
great.
sir.
Okay. Yeah. And next thing is that if there were no unbalanced forces of friction and air resistance, a moving bicycle would go on moving forever. So it means that if suppose that there is a bicycle moving on a road, so if there is no friction and no air resistance, because air also gives some resistance to move. So that's why the bicycle will move forever. And if suppose that there is no friction between the tire and the ground, the bicycle will slip, because that is,
Yes,
friction is the force that is helping to basically ride the bicycle in a proper manner. Okay?
sir, will it touch the
Astin,
road? Like it will be like when it's moving, will it be touching the road?
little bit, I didn't get your word, Sages.
Sir, when the bicycle is going, will
Mhm.
it touch the road or it will be like in air?
No, it will touch the road. Obviously, it will touch the road. It will be slippery. You must have seen that when you slide on a, you can say icy floor or
Yes, sir.
tiles. Suppose that tiles, there is a ground with the tiles and the water is spilled on it. So what will happen? You will slip it. Even with, you will be having some contact with the floor, the contact would be very less. It means that the friction would be very less. So that's why you will slip it. Yeah.
Okay, sir. Thank you, sir.
Any doubt so far? 21?
No, sir.
No, sir.
Sure, that's great. That's great. So is this clear to all of you? Ifra, Tejas, Astitva,
Yes, sir.
Sara, Farhan,
Yes, sir.
Safia,
Yes.
Yes, sir.
Rishad. Chalo, that's great.
Yes, sir.
Okay, so this is all about the unbalanced forces. So only this is the only basic concept that is there. Okay. So now let's discuss the first law of motion. Just a second, everyone. Just allow me a second. I'm sorry for the interruption. Yes, everyone. So now let's discuss the first law of motion. And in the first law of motion, basically inertia is involved in it. Okay. So we will be discussing inertia along with the first law of motion. Am I clear?
Yes, sir.
Yes, sir.
Chalo, that's great. So as you can see this thing that the first statement that is saying it is the first law of motion. A body at rest will remain at rest and a body in motion will continue in motion in a straight line with a uniform speed unless it is compelled or unless it is compelled by the external force. Okay? Clear everyone? So
Yes,
to
sir.
change
Yes, sir.
the
Yes, sir.
state,
Yes, sir.
to change the state of the object, it is required to basically to apply some external force. Okay? Right? That's great.
Yes, sir.
Okay, so now
Yes,
let's
sir.
discuss about the inertia. So the tendency of a body to remain at rest or it moving to continue moving in a straight line. Okay, so it means that the tendency of a body to remain at rest or if it's moving, so it will continue to be moving in a straight line unless external force is applied, right?
Yes,
Clear
sir.
Yes,
everyone?
sir.
Yes, sir.
Yes, sir.
Chalo, that's great. Okay. Next is, so now let's discuss the inertia. So inertia is a property due to which the change, basically due to which the body resists to change the state of the state of the body. Am I clear?
Yes, sir.
So inertia is the property
Yes,
due to
sir.
Yes, sir.
which, okay, due to which it resists the change in the state of rest or of uniform motion. If suppose that body is in rest, it will be in the rest unless the external force is applied. If even the external force is applied, body will resist to be in rest. And if the body is moving, and if you want to stop the body, moving body, so if you exert some external force, the body will resist that. No, I just wanted to continue the uniform motion. So please do not stop me, right? Clear everyone?
Yes, sir.
Yes, sir.
Yeah,
Yes, sir.
that's great. Okay, you must have seen, how many of you have seen the kabaddi game? You must have seen when the person goes to the
Yes, sir.
raid, when the person goes to the raid, so when everyone basically catch him, something like that, so basically he resists, right? So to basically like lose the grip. So inertia is a similar kind of thing. You can imagine, right?
Sir, I have
Clear
played it.
everyone? Okay,
Yes,
you
sir.
are
Yes,
okay.
sir.
That's great, Astitva. That's great. So at the school level or like something state level, something like that.
Sir, school only.
As a school, chalo, theek hai. Intra or inter? Inter
Yes,
school or
sir.
inter school? Inter school competition or inter school competition?
Sir, like like within class itself.
In is
Our
it
class.
acha, acha, our class? It means that in the lunch break and the sports period.
Yes, sir.
Yes.
Chalo, theek hai, that's great. That's great. Okay. Yeah. So next thing about the inertia is that inertia depends on the mass of the body. This is a question I think everybody has given the test so far of the force and laws of motion.
Yes, sir.
Yes, sir.
Okay, Tejas has Tejas and Astitva. What about Farhan, Safia, Irshad?
Sir, I have Which given it, test? sir.
Sir,
Checked.
which
Okay.
test?
I'm saying the force and laws of motion test.
Yes, sir. Right.
Okay. Okay, everyone, why did everyone switch off the video? I just took a 1 minute break because there was some urgency. So please switch on it.
Right.
Okay, that's great. Now, next thing is that inertia depends on the mass of a body. How heavier objects have more inertia than lighter objects. Clear?
Yes, sir.
So heavier objects have more inertia. It means that heavier the mass, or heavier the body, heavier will be like more will be the inertia, and more
sir.
it will resist. Suppose that there is a bus and there is a car. So bus has a very greater mass as compared to car. So bus will
Yes,
have
sir.
the more inertia and it will resist more. You cannot move a bus with the single-handedly or with a single person. You have to
Yes, sir.
like you need at least I think so 7 to 8 people are required to move the bus. 7 to 8. I think so minimum. I'm not sure. Maybe more would be required. But in the car,
Yes, sir.
even a single person can easily move the car because of the
Yes, sir.
less inertia produced by the car. Am I clear to all of you?
Yes, sir.
Yes.
That's great. Okay, that's great. Next thing is that inertia. Okay, so a stone has more inertia than a cricket ball because stone has more mass than a cricket ball, right? Stone can be almost about 10 kgs, 15 kgs, even 100 of kgs. Stone can be, but a cricket ball is only like 400 gram or maybe 500 gram, or high to high it could be 700 or 800 gram if the ball is is used in the international games. Is this clear to
Yes.
all of you?
Yes.
Yes, sir.
That's great. Okay. Any doubt so far to anyone?
No,
Safia,
sir.
No,
Tejas,
sir.
Irshad,
No,
Astitvas, and Ifra and
No, sir.
Sara.
No, sir.
No, sir.
Chalo,
No,
that's
sir.
great. Okay. That's great. So this is our first class of the revision now.
Yes, sir. No, I think second, sir.
No, this is the first. We have discussed only the motion in the last class.
Oh, okay, sir.
Yeah, they just forgot about the order. Chalo, bye-bye. Okay, next thing is that, just a second. Yeah, next thing is that when I have, now we are going to discuss the, you can say, the consequences of the first law of motion. The first consequence, and very you can say popular example that comes into the exam, and you must have seen this thing in your real life as well. When a hanging carpet is beaten with a stick, the dust particles coming out of it, this is because the force of stick makes the particle, or you can say makes the carpet move to and fro. It means that in a like pendulum motion, when you beat a carpet, so it will be like, it will move like this. Yes or no, everyone?
Yes, sir.
Yeah. So
Yes,
that's
sir.
why that basically that forces, or you can say that forces the dust particle to move, or basically to get separate from the carpet due to the inertia. Okay. So the particle want
Yes.
to remain at rest, so that's why they remain at rest. But the carpet moves, so that's why the
Carpet moves.
particles are separated from them. Clear?
Yes, sir.
From it.
Yes.
Chalo, that's great. Achha, one more thing I've seen, I've, like those who have given the test so far of the motion and the force and laws of motion, I've seen one thing. Nobody did the revision of the notes. Even like explanation, even the simple pace, the simple straightforward question was there, and nobody did the explanation properly. So it's very important. It's very necessary to revise the notes, because everything that is written is basically the extraction, the summary of the book. You don't need
Yes,
to
sir.
write all the things, and you don't need to read all the concepts prop. So this is the actually the summarized part of the book or the motion chapter. That's why we make notes. Yes, everyone. So
Yes, sir.
if you are not revising the
Yes, sir.
notes, so what is the use of the notes then? Please do let me know, everyone. Those who
Nothing,
have
sir.
given the test so far, I'm asking from them. I'm not sure that
Nothing, sir.
who has given the test and who has not. But I've seen this thing that like Irshad, Tejas, Astitva, Farhan, they have given the test for motion and force and laws of motion. And Sarah was also there. Sarah and Chike. So it's very important to revise the notes, everyone. And it's like I'm saying to all of you that those who have not given the test yet, they will be giving. But please do revise the notes. Okay? Revision is very necessary.
Yes, sir.
Okay? So
Yes, sir.
everything is there, even very crisp. That's why I write everything. Crisp points are there. You just have to write it and you will secure the marks. I'm not saying
Yes.
just rectify, like a rectification process, something like that, right? Everything comes
Yes,
with
sir.
a concept. So I understand explain the concept. You have to understand it, then implement it. The
Yes, sir.
reason.
Sure,
Okay,
sir.
got it, everyone?
Yes, sir.
Yes, sir.
That's great. Okay. Now let's understand when a running car when a running car or a bus stops suddenly, the passengers are jerked forward. It means that they are moved forward due to the inertia. The passenger wants to remain in the motion, but the bus is stopped, so that's why they come to rest, and that's why they feel a forward jerk. Okay, everyone, got it?
Yes, sir.
This is due to
Yes,
the
sir.
change in inertia or change in state. Am I
Yes,
clear
sir.
to all of you? Please do let me know.
Yes, sir. You're clear, sir.
Yes, sir.
Any doubt so far to anyone?
No,
No,
sir.
sir.
No, sir.
That's great. That's great. Next is when a car, it is now next thing, when a car suddenly starts. So when a car or a bus suddenly starts, the passengers falls backward. So suppose that I travel a lot in the metro. So metro is a very good convenience in Delhi, right? Okay. So when I travel in the metro now, so suppose like as you know, Delhi is a very busy city. So
Yes, sir.
I usually don't get the seat, so I have to travel like in a standing position. So if I do not like somehow like a pipe or something, I do not take a support. So I feel a very like backward force, like very higher magnitude backward force that someone is pushing in the backward direction. Right.
Yes,
So that is the reason because metro accelerates with a very greater magnitude. Right.
sir.
So that's why you feel a backward fall when
Sir.
basically when a bus or a car. Yes, they just
So magnitude is direction or what?
magnitude means value of the number. Suppose magnitude size of the that quantity. Suppose 2 meter per second. 2 is the number.
Okay, sir.
Magnitude size that is telling you how big is it. Okay.
Okay, sir.
So that's why the metro accelerates at a very greatest rate. Right. So it travels like 150 km/h, something like that. So the acceleration is very good. So that's why we feel a very greater magnitude backward fall. Okay? So due to that, the passengers tend to remain at rest, but the car wants to move in the forward direction. That's why you feel a backward force. Am I clear to all of you? Please do let me.
Yes, sir.
Yes,
Any
sir.
doubt
Yes,
so
sir.
far to anyone?
No, sir.
No,
No,
Okay,
sir.
right now I'm giving the example so that you can relate everything with the real world because we have completed the syllabus. Right now, our time is to give the implementation process. If we give the time to the implementation process, right? So please
Yes,
do
sir.
relate everything in the real life. If you relate
Yes.
everything in the real life, that would be much easier to understand physics. Physics is all about real life.
Yes.
So if you relate everything with the real life, so you must understand in a very proper manner. Am I clear to all of you?
Yes,
Sarah,
Yes,
Farhan,
sir.
Astitwa,
Yes, sir.
Safia, Irshad, Tejas,
Yes, sir.
Ifra.
Yes,
Yes,
sir.
sir.
Yes, sir.
Check. Okay, that's next one. It is very dangerous to jump out from a moving bus because the jumping man who is moving with the high speed of the bus would tend to remain in motion even on falling to the ground. Okay, because suddenly when you jump from a bus, the inertia is the state of the body is changed to rest. Oh, sorry, motion to rest. So there is a sudden change. Okay, so if you change the state in a very quick manner, there's a very high chance that you will fall on the ground and you might get hurt. Clear, everyone?
Yes, sir.
Yes, sir.
Yes, Irshad, you said something?
No, sir, I said yes.
Okay, that's good. Okay, so it's very important to keep this thing in mind. So do not ever try this thing because I have seen so many things on the social media that some of the person have basically lost their life due to this thing. So it's very, very dangerous and even deathly. Sometimes it can be deathly. So it's humble request. Whenever you are using any kind of convenience or any kind of transport, please deboard and board properly with proper precautions. Okay? Do not jump unless the bus is stopped and do not board unless the bus is stopped completely. Is this clear
Yes,
to
sir.
all of you? Everything, not it is bus, metro, or anything. It could be anything, right? So it's a
Yes, sir.
humble
Clear,
request to
sir.
all of you. Yeah, that's great.
Yes, sir. Clear.
Yes, sir.
Because with the physics, I want to raise the awareness among all these students.
Yes, sir.
Safia, could you please tilt your camera a little bit? I'm not able to see your face because only your spectacles are visible to me only. Okay, bro. Is this clear to all of you?
Yes,
Yes,
sir.
sir.
Clear, sir.
Yes, sir.
Chalo, that's great.
Sir, I
That's
messaged you
yeah.
something.
Oh, just a second. Yes, that's no issues. Like if you have any issue and or
Yeah,
like
because like
any
if I
internet
keep
issue,
it on, it's like
I know.
I can't hear you clearly. That's the thing.
Yeah,
Now
your
I'm
voice would
I kept
be
it up.
lagging as well for me. No issues, no issues, no issues. That's acceptable. Okay. So please do let me know, everyone, is this is clear to you or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Okay, now next thing is that the momentum. So momentum is the topic that is related to the second law of motion. And this topic will give you the definition of force in terms of mass and acceleration. Clear?
Yes, sir.
Yes, sir.
Okay. The momentum of a body is defined as the product of mass and velocity. Clear?
Yes, sir.
Yeah.
Yes,
So
sir.
momentum is basically the product of mass and velocity. Could you please tell me momentum is basically dependent on which of the following quantities, mass and velocity, or only mass or only velocity?
Sir, Mass and velocity.
Mass and velocity. Okay. So basically, momentum is depending on both the parts, right? So momentum is depending on mass as well as the velocity, right, everyone?
Yes, sir.
Yes, sir.
What happened, Farhan? Is everything fine?
Yes, sir.
Check. Okay, now next thing is that momentum is a vector quantity. It means that it has both magnitude as well as the direction, right?
Yes, sir.
And SI unit of momentum is kg meter per second. So mass is kg, velocity is meter per second. Is this clear to all of you?
Yes, sir.
So that's how you will
Yes,
get
sir.
the SI unit of the momentum. That's great. Okay. Next is the quantity of motion in a body depends on the mass and velocity of the body. So momentum tells you that how much motion is there possessed by that body. So it depends on mass as well as the velocity. Clear, everyone?
Yes, sir.
Irshad,
Yes, sir.
in which exams? So it depends on like school by school, because right now in the ninth standard there is not fixed marking. It varies from school to school, right? But in the boards there is a fixed marking because the paper is produced, or you can say that set by the CBSE board itself. So in the school exam, some of the school will give more weightage to the force and laws of motion. Some of the school will give more weightage to the motion chapter. So it depends. But by the mean, if you are basically having so only 2 chapters are coming right now. So the weightage would be like you can say similar. Like if suppose that 27 marks paper or 26 mark paper is distributed for the physics. So the 13 marks would be distributed over the 2 chapters. Okay? So it depends. But in the final exam, that varies from school to school, because school basically set the paper in the final exams, because in that CBSE is not involved, right? But in India, in the public schools, like basically, I'm basically graduated from a public school in the ninth and like till 9th and 12th. So yes, so basically in that public school, basically public school means government school in the India, government school. So basically the paper is distributed by the CBSE itself, even for the 9th and 11th standard. But private school do the same. They create their own paper for the different weightages. Even they have like some of like suppose that if you compare the syllabus of the Indian student and the Middle East student, they both are different a little bit. Some like you don't have the conservation of momentum, but Indian student have the conservation of momentum,
Yes.
right?
Sir, I
You don't
messaged
have.
you
Yes, sir.
something.
Yes, Tejas, you want to ask something? Please tell
Sir,
me.
I messaged you something.
Achha, you messaged me something. Yeah, okay, Tejas. I will ask them to arrange it. No need to worry. Because right now, like everyone is busy, like in the revision test series and the revision classes. So a little bit hectic schedule is there. So
Okay,
I
sir.
just forgot it. Okay,
Okay,
I'll
sir.
basically arrange it. Everyone clear?
Yes,
Yes,
sir.
Chalo, that's great. So, okay.
Yes, sir.
Now let's understand the cricket ball. So, cricket ball is not that much heavy, but it still, but when it is thrown with a higher speed, so it still acquires a large momentum and will hurt a lot. Sometimes it could be deathly. So, if I give you an example, in 2014, no, in 2016,
Sir, I
there was
faced it also.
yes, Tejas, Asif, you are saying something?
Sir, this example which you're telling, I have faced it. It was very hurtful. I mean, painful.
Yeah, yes. So basically, that was an Australian batsman who got the hurt by a ball on the head, and after 2 or 3 hours, maybe, or maybe even after a day, he passed away.
yes, sir.
So you can see that the cricket ball, basically, if some like a cricket ball hits at the wrong place, so it could be deathly and it could be more worse. Okay?
Yes, sir.
So whenever you are playing sports, do proper precautions. Okay? Take the proper
Yes,
Sir,
precautions and all the things.
sir, it
Yes,
was
there
close
is
for me.
It was.
Like almost close for me because once I played without helmet, ball went passing.
Yeah, the same thing. Yes, I have experienced a lot of times. Same thing.
Yeah.
Okay, chalo, that's great. I used to scare a lot of from the you can say short balls.
sir.
Okay, chalo,
Yes,
that's
sir.
great. Now let's think. A car or a bus may not be running at a higher speed, but still they are of heavier mass and will have the high momentum due to the mass. because momentum depends on the mass. Even they are not moving with a larger speed, so the momentum is basically increased by the mass itself, so which may hurt the people. Even if suppose that car is moving with a higher speed as well as the mass of the car is very high, so if you combine them, so that would be a very worse and very deathly combination. So you must have seen that
Yes,
the
sir.
accidents happened, so they are basically more worse, like if the car is traveling at the higher speed, right? And if the car is traveling at a lower speed, so they could be minor injuries but not that much severe. Clear, everyone?
Yes, sir.
Yes, sir.
Any doubt to anyone?
Yes.
No, sir.
No,
No,
sir.
sir.
Chalo, that's great. Okay. So, like along with these physics, we are discussing all the real life things that you should understand properly, because right now you are
Yes,
in an age in which you are more excited and more energetic. So that's why all the things are required to
Yes, sir.
understand. Okay, that's great. So momentum is considered to be a measure of the quantity of motion of a moving body. Clear, everyone?
Yes, sir.
Sara,
sir.
Asitva,
Yes, sir.
Tejas, Safia,
Yes, sir. Clear, sir.
Saif,
Okay,
Farhan,
sir.
Irshad. Okay, that's
Yes.
great. Okay. Chalo, that's great. Sample problem first. So this is the basic question, that what is the momentum of a man of mass 75 kg if it's moving with a velocity 2 meter per second. So the simple formula is P equals to mv. You just have to multiply both the quantities to find out the momentum. So 75
Yes,
into
sir.
2 would be 150 kg meter per second. Clear, everyone?
Yes, sir.
Yes, sir.
That's great. Chalo, that's great. Next is a body of mass 25 kg has a momentum of 125 kg meter per second. You have to find the velocity of a body, right? So momentum is given to you, mass is given to you, you just need to find the velocity. So velocity could be found out by dividing the momentum by mass. So momentum by mass would be 125 by 25. So it would
Yes,
be
sir.
5 meter per second. It means that the body is moving with a velocity of 5 meter per second.
Yes,
Clear,
sir.
everyone? Or
Yes, sir.
18
Yes, sir.
kilometer per hour.
Yes.
Okay, that's great.
Yes, sir.
Next, yes, you said some, anyone said something?
I did not say anything.
No, sir.
Okay, check. That's great. Just a second. Next is the
Yes.
calculate the momentum of a toy car of mass 200 grams with a speed of 5 meter per second. So mass is not given in SI unit. So that's why you have to convert it into SI unit, because mass is the SI unit of mass is kg, right? And speed is 5 meter per second. So it would be 200 grams. So 200 grams would be 2 by, so if you want to convert it into kgs, so it would be 1000 kg, right? So 2 by 1000, 200 by 1000. So it would be 2 by 10. So it is coming out to be 0.2 kg, right?
Yes, sir.
And velocity is 5 meter per second. You just have to multiply it. So 2.25, 0.2 into 5 would be 1 kg meter per second. Clear, everyone?
Yes. Yes, sir.
Yes, sir.
Achha, one more thing. I just wanted to say that I have discussed one thing, that some of the students like are not able to solve this simple algebra question, simple algebra like 0.2 into 5 and something like that in the exam. So please work on the multiplication addition in the decimal portion as well. Okay, everyone? So this
Yes,
would
sir.
be a very helpful, you can say, move for you, right, everyone? Astitva, Tejas, Farhan, Safia, Irshad,
Yes, sir.
and
Yes, sir.
Sara,
Yes, sir.
Ifra.
Yes, sir.
Check. That's good. Safia, are you there in the class?
Yes, sir.
Okay. What happened? Is everything fine?
Sir, I have a network issue.
Acha, no issue, no issue. कोई बात नहीं, no worries. ठीक है? That's great. Next thing is that let's understand this question. A man throws a ball weighing 500 grams vertically upwards with a speed of 10 meter per second. So basically, when you throw a ball in the upwards direction, right? Something like that. What will be the initial momentum? What will be the momentum at the highest point of the body? So this is the question that we have discussed as well in the class.
Yes, sir.
And this is the question like nobody solved it. Okay. So what will be the initial momentum? Initial momentum means the body, sorry, the speed with which the body is thrown in the vertical motion, right? So
Yes,
initial
sir.
means the starting point. So mass is half kg, so it would be 0.5 kg, 10 meter per second. So if you multiply it, so it would be 5 kg meter per second. Clear, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
That's
Yes, sir.
great. Now let's talk about the momentum at the highest point. So as I've told you, when you throw a ball in the upwards direction, at the highest point, the velocity of the ball would be 0. That's why the ball comes to the ground itself, right?
Yes, sir.
If the ball will not lose its velocity, so it will go in the upward direction, and basically it will go into the outer space without anything. So that would be much easier to send the space and all the things without any fuel. Suddenly you just have to push a little bit, and the body will move in the space by itself. But that is not the case. So at the highest point, the velocity of that body would be 0. Am I clear? That ball would be 0.
Yes.
Yes, sir.
Yes, sir.
Okay? And it means that velocity is 0, so momentum would be 0. Could you please tell me, everyone, if it's clear to you or not?
Yes, sir.
Yes, sir.
Any doubt so
Yes,
far to
sir.
anyone?
No, sir.
No,
No,
sir.
sir.
No,
Sure?
sir.
Yes, sir.
Chalo, that's great. Next thing, let's understand how much momentum will a dumbbell of mass 10 kg transfer to the floor if it falls from a height of 80 centimeter. Take the downward acceleration as 10 meter per second square. So this question is important because it involves the acceleration due to gravity. So this downward acceleration is the acceleration due to gravity that is exerted by the earth on the body. So when you basically fall from a high point, so what will happen? You will fall. There is an acceleration acting on the body that is basically attracting towards the surface.
Yes, sir.
Everyone, yes or no?
Yes, sir.
So that is talking about this. So mass is 10 kg. Distance is 80 centimeter from the height from which the dumbbell is thrown. So that would be 0.8 meter. Acceleration is 10 meter per second. So as you can see this thing, everyone. So acceleration is a negative, like both, is a vector quantity. So it could be both negative and positive. So right now I'm assuming that downwards direction would be positive because the motion is along the downwards direction.
Yes.
Clear, everyone?
Yes, sir. Yes, sir.
Sir.
That's great. Okay. Next thing is that, okay, so u is 0 because when you drop a body, so initial velocity would be 0 of that body, and it will
Yes, sir.
increase automatically when it will fall through it. Yes or no,
Yes, sir.
everyone?
Yes, sir.
Yes, sir.
That's great.
Sir, any assessment is
Yeah.
there?
No
After the
assessment, no
class?
assessment. Everything
Okay,
is fine. Everything is done. No
Okay,
assessment.
sir.
Okay. So if you want to calculate the final velocity with which the body, because we need momentum, so final velocity is required with which it will hit the ground. So final
Yes,
velocity
sir.
could be found out using the the third equation of motion, right? So it would be v square minus u square equals to 2a. So the initial velocity is 0, and v square is equals to 2 into 10 into 0.8. So it is coming out to be 16, and v is coming out to be root times of 16. So
Sir,
you must,
sir,
yes, Tejas,
sir, can we write velocity 4 meter per second?
4
Yes,
meter,
you have written. Yeah, nothing, sir.
it's written.
Yes, sir.
So there you go. Square of both negative and positive is same. So square of
Yes, sir.
negative 4 is 16. Square of positive 4 is also 16. But as you know this thing that the speed is not the negative quantity.
Yes, sir.
So that's why I'm assuming this only as positive, right? Okay. So you will understand this thing in the 10th standard, the quadratic equation in the chapter quadratic equations, right? So, okay. Clear, everyone?
Yes, sir. Yes, sir.
Sure.
Sir, will it come in maths?
Yes, it will come in maths. Quadratic equation.
Okay, sir.
So it would be 4 meter per second, and the velocity is this 4 meter per second. The final momentum, or you can say the momentum with which it will hit the ground, is 10 into 4. That is coming out to 40 kg meter per second. Clear?
Yes, sir. Yes.
Please do let
Yes,
me know,
sir.
everyone, if it's clear to you or
Yes,
not.
sir.
Yes,
Is
sir.
there any doubt so far to anyone?
No,
No,
sir.
sir.
Sure?
Yes, sir.
Yes, sir.
Okay, that's great. If I give you one question, would you like to solve it?
Yes, no, sir. Yes, sir.
No, yes, no.
Yes,
Why are you
sir.
confused? Just a minute, everyone. Please do the B part of this question. B part, 20 centimeter per second.
Okay, sir. The second part, right?
Yes.
Okay.
Any answer from anyone?
Just 1 second, sorry.
Okay, Tejas. Anyone else? Sarah and Irshad, Farhan, Tejas, Ifra.
Sir, I'm doing it, sir.
Sir, 2 kg per second.
Just a second, Tejas.
Yes, sir.
Yes, everyone. So let me check who got the answer. Okay, Tejas, Safia, Ifra. Check. Okay, now let's do the question. The question is saying that we have to find the momentum when the car is moving with the velocity 20 meter per second. So V is basically 20 centimeter per second. So time basically seconds isn't already in SI unit. We just have to convert it into meter per second. So
Yes, sir.
20. So centimeter, to convert centimeter, you have to divide it by 100 meter per second. So this will get cancelled. So it is coming out to be 0.2 meter per second, right? So the momentum would be mass into velocity, that is 0.2 into 10. So this is coming out to be 2 kg meter per second. This is the answer. Please do let me know, everyone, if it's clear to you or not.
Yes, sir, it's clear, sir.
Is there anyone who is having doubt till now?
No, sir.
Sure,
sir.
that's great. Okay. Okay, that's great.
Sir.
Everyone. So yes.
So can we convert this after we get the answer?
Into what form?
7 kg meter per second.
Kg?
Meter per second.